Hello everyone, my name is Bart Waardenburg. I'll be the final one and the last one between you and the bar, so I'll try to keep it worth your while. I work as a developer, a front-end developer at ANWB. I think most of you around here know that company, but for the ones from other towns and villages across the world, we are basically AAA, as in the United States, or the ADAC as in Germany. We're a motoring club, but today we do all kind of stuff. We have a shit ton of web apps and apps all over the place, and that's it. What do we want at ANWB? Our stakeholders, they want this. They want us to deliver high quality applications for our users while regularly releasing new features, which is basically, I think, what every one of your stakeholders wants from you. So nothing new there. But how do you do that? How do you get to that point that you can deliver high quality and still keep a nice pace with delivering new features? One of the things you can do to make that happen is to have a code base with a lot of tests. That's why I thought about giving a talk about how we handle testing. First of all, I think it's really hard to figure out when to write a test, when not to, all those kind of stuff. So when I looked at our code base, I thought, hey, we basically have three kinds of tests scattered around. And so I thought of the title, we have 3 layers. But as you might have guessed, when I started writing this talk and preparing, I noticed that we actually have 4 layers. So let's start with the first one. We'll be going through the pyramids from the bottom to the top, and I'll quickly show a small example of how it looks, and hopefully at the end of the talk you have an idea about how you can handle your testing in each of those layers. So the first one is static analysis. This is the layer that I thought of all the way on the end. Well, what's static analysis? Static analysis is the analysis of software that is performed without actually executing programs. Examples of static analysis are, for example, linting and types for JavaScript. Well, let's show some hands. Who uses linting in their development workflow? Nice, most of us. And another one who uses types for JavaScript, like Flow or TypeScript. That's a bit less. But anyway, those are 2 kinds of ways to improve the quality of your code and to make sure that the thing you deliver is actually that what you want it to be. I just noticed this today. There's some research done by, I think, University of London together with Microsoft, which had this conclusion: using Flow or TypeScript could have prevented 15% of the public bugs for public projects on GitHub, which I thought was pretty massive, since it's not really that big of a step to introduce it in your workflow. This is a small example of using, in this case, Flow to make sure there are no bugs in your React components. Let's see, how does the... on top here, I have a type definition for the props that I'll be using in this small button component. It basically says it has 1 prop, which is text, which should always be there, and it's a JavaScript string. Here's the component, and what it does, it puts the text inside the button. But what happens here, someone, or me, is using the component somewhere and is not passing a string, but is passing an array, which would cause some kind of error. But Flow or TypeScript would be able to catch that error and tell you even already in the development workflow that, hey, we're expecting a string, but you're passing an object, or array in this case. Go fix it. But you can have every single variable and function completely typed and linted, but still have none of your functions doing what they should be doing. An example is this. This is just a simple function which should multiply two numbers. I've got it all perfectly annotated with flow. The types are correct. The thing it does, it returns a number. But when you look closely, it doesn't multiply, but it does an addition. So linting would say, oh, no problem, it's perfectly fine. And flow would say, yeah, great, go ahead, push this to production. And that's where the second layer of testing comes in, which are unit tests. And who here writes unit tests for their code? Hands. Wow, that's quite a lot. That's nice. Well, basically, a unit test is a way of testing a unit, the smallest piece of code that can be logically isolated in a system. To make it a little more simple, it's testing whether a function does what it should be doing. There are several ways to do that. Here I have taken the multiply function I showed earlier, still doing the wrong thing with addition. And I've written a simple test using Jest, but any framework can do these kinds of things. This is a really simple function. So I can just say, I expect a multiplication of 4 and 3 to be 12, which I assume is correct. If you run it in Jest in your terminal, you will see that it expected to be 12, but we did an addition, another multiplication, so it returned 7, and it told you to go fix it. Another really cool, relatively new way to test your code, and especially useful for testing React components, is snapshots. And a snapshot is a test that verifies that a piece of functionality works the same as it did when the snapshot was created. It's like taking a picture of something and doing some changes in your code and taking a picture again of that same piece of code, or better to say the output of your code, and comparing those two. So for example, I have here again a simple button component which takes a parameter which with a type, which should be a string. It makes that into a class name. And in here we have the snapshot running. It uses a helper function created by the React team to turn a component tree into a JSON object, so that JSON objects can be stored, and next time the test will run, it will compare those two JSON objects and see if anything has changed. If all goes well, it says, yay, everything is great. But if it didn't match the new way because you changed something somewhere and it touched the code you've written, you would get an error. It says fail, and in the bottom here you will see what exactly has changed. I have changed some code to pass the bad string instead of the good string, and it will display in your terminal or any other environment where you're running the test that it has failed. But again, you can have every single component and function unit tested, but you still have none of your functions working together like they should, because you're only testing whether they each separately do what they should be doing. Here I have a simple example. The multiply function is this time working correctly. I've got a simple alert number function which alerts a value, and I've built a button. And I wanted the button to alert a number multiplied when you click on it. But as you can see, I forgot to include the alert number on the onClick, but I did it on the on-mouse enter. This would pass the unit tests. Snapshot will display, hey, it has an onClick handler, which has a function. It doesn't show exactly what kind of function it was, but it's there. Which brings us to our second layer, the integration testing layer. And integration testing is the phase in software testing in which individual software modules are combined and tested as a group. When you hear this, are there people who are using integration tests in their software who are building that? Quite a lot. Nice. Looking good. I think they're the hardest part to get right. So I write not a lot of them. The snapshots are easy. You just write one line and it all goes great. But with integration tests, you have to think a lot more about things. And when you talk about integration testing while using React, Enzyme is probably the most popular and most useful tool. Here we have the same button component again, with the on-click and the on-mouse enter, and here in the bottom we have a test case, where we say the button component should run a function on click. And when we click it, in the test we use Enzyme to simulate a click. We want the alert number function, which we have mocked here with the jest helper, that just tracks how many times there has been interaction with the function, to assert that it has been called once. And when we run it, we'll see that it has failed because it was called 0 times. But again, you can have everything working together completely as intended, but still have an empty screen as an application. Let's take this for example. There's someone who wrote this beautiful piece of code which would hide the complete application. It could be some weird script someone left somewhere as a joke, or I don't know, but it could happen. That brings us to the final layer of the testing pyramid, which is the user interface testing. Who here writes user interface tests, are sometimes known as end-to-end tests or regression tests, quite a lot of people. Some companies have special QA engineers who write them. Some people don't do them because they're hard. User interface testing is the process of testing a product's graphical user interface to ensure it meets its specification. When you look at tools to do these kinds of tests, there are really a lot of them. I have listed here a couple at the top of my head, but there are even more. Probably the most popular and the oldest one is Selenium, or a WebDriver, which has been here the longest, but people are not really happy with Selenium, so they're creating their own frameworks around testing. All of their ups and downs and good use cases and bad use cases. But the two I'm going to show you little short slides about are Navalia and Chromeless, because they bring something to the table that the others made a little harder or are just not that good at. This is an example of Navalia. Navalia uses headless Chrome to test your application or your web page, actually. And what we're doing here in this function is we use a library called just image snapshot, which does probably what you think it does. You can tell Chrome to go to your web page, to wait for a certain element to appear. You can have it take a screenshot, and after that you can check if that screenshot matches the previous screenshot. This is a little example of an application I'm working on. This is the ANWB route planner, used by a lot of people who don't know how to find Google Maps. No, kidding. We do have things that they don't have. But anyways, I instructed it to do this. It took a snapshot. It said it passed because it was the first snapshot. And now I've run the code second time. And what it does, it compares the new image with the previous one, and it creates some sort of image comparison. And what happens when it fails, maybe someone did something that they shouldn't have been doing, it will say that the expected image did not match or wasn't a close match with the previous one. This example has a big, lovely cookie, a pop-up all over the application. And in the middle here you'll see a small heat map, which displays the red things from this has changed. And again, just like with the regular snapshots, you can tell just whether that was what you wanted or if it wasn't. And the last cool example of a tool to do visual testing is Chromeless. And what Chromeless brings is it's a similar syntax. It's almost the syntax that's used on all other tools. But the cool thing it does, it allows you to run the headless Chrome browser in a AWS Lambda function, which solves one of the biggest problems with these kind of tests is that Selenium tests, for example, are really slow. They take a lot of resources, and it can sometimes take 20 minutes to complete all your tests if you have a lot of them. And with AWS Lambda, you can spin up as much functions as you want. Then when it does, it has a Chrome headless running there, and you can send your commands through the terminal to those instances, which will mean that you can run as many tests parallel as you want or as your computer can handle, which is quite a lot. And it's really easy to set up. Chromeless provides a serverless package you can set up by just entering some API endpoints and API keys. And then you can run hundreds of browsers in parallel. And you might say, well, that can get expensive really quickly. Well, it turns out you can easily run over 100,000 tests a month for free in the free tier, because those tests only take roughly 8 seconds a piece, and it just spins them up and it turns them down again when they're done. So it doesn't take that much time, and which is great. So this is the pyramid. It's complete. When you go up the pyramid, testing gets harder, or there are more things to worry about, but the actual value for your users also goes up, because with a perfect user interface test shebang, you can cover all the edge cases, and with just static analysis you can't. It doesn't mean that you don't have to do them, just know that they're all there. Thanks for listening, and happy testing.